on PW Gate Wallah channel. In this series of operating system, we are continuing the CPU scheduling algorithms. We have discussed a few algorithms, FCFS, SJF, and yesterday we have discussed SRTF, solved a few questions also and practiced. Today we are going to learn and then solve the questions on the algorithm, priority based algorithm. So we will start the priority based algorithm today, and in the priority based algorithm, what type of it is, preemptive or non-preemptive. Then we will see starvation in priority based algorithm. Then there is a solution of problem called as aging, that also we will see, and a few questions of course we will practice. Quickly just let me know if you guys are okay with my audio and video so that we can start the session immediately. If you guys are ready for learning today, just let me know so that we can start the session. So comment in the comment box so that we can start the discussion of the day. Fine. Okay. Let's start the discussion. Priority based algorithm. So scheduling criteria is definitely priority. Sir, what is the priority of the process? It will always be given in the question. Each process has this priority and so on. Sir, if two processes are having equal priority, then what should be the tiebreaker? There will not be such case. In the question, till the date, whatever gate question have been asked, each process had a unique priority till now. So there is no any question till now in which if two processes are having equal priority, such kind of case has been asked. If at all it will happen in the near future, it will be given in the question. You don't have to bother about it. You don't have to worry about it. So priority is the scheduling highest priority process first. I am writing highest priority process to be scheduled first. But there will be tiebreaker. Sir, tiebreaker is nothing here. If there will be a tie, though it will not be, then it will be given in the question. You don't have to have any kind of speculations, assumptions, etc. Always read the question carefully and you will get to know that what is the tiebreaker if two processes are having same priority. Type of algorithm is non-preemptive, preemptive, both. Hey sir, both? Then how we will understand what type of question we will have to solve? Beta ji, it will be again given in the question. When you will solve the question, any gate question, it will always be given that this particular question you will have to solve with what type, preemptive version or non-preemptive version, always will be given. Okay, now I do have a question for you guys. The question is very simple. Let's say three processes are there, P1, P2, P3, and their priority numbers are given. Priority number of P1 is 6, P2 3, and P3 is 5. You tell me which particular process is having highest priority. You tell me which process is having highest priority. Okay, see, the largest priority number is 6 with P1. Smallest priority number is 3 with P2. But my dear friend, how do you understand that biggest number is biggest priority, highest priority, or lowest number is highest priority? How do you know that? Again, that will be given in the question. You don't have to again put any kind of efforts here. You don't have to remember it. There is no any standard, there is no any default case. Something given in the question always. So we cannot say that this is highest priority process or this is highest priority process. No, why? We don't know that biggest number higher priority we have considered or smallest number higher priority we have considered. It will always be given in the question somehow. How? we will see and always remember. Okay. Priority is always mentioned in the question. So please don't be confused. Ever, ever, ever. Okay. Fine. This is a question. Look at this. Priority based algorithm. This is the question. Arrival time of process is given. Burst time of the process is given. Priority is given. P1 have priority 4, P2 5, P3 6, P4 10, P5 9, P6 7. All processes having priority, and look at this in the question given. In the question, it is clearly mentioned that 10 is highest. Now you guys are smart enough. No, I believe it. You and your family does not believe, or they do believe. I don't care about it. I believe that you guys are smarter than most of the people in this world. So you can understand, if here in front of this highest is written, you just see 10 is the biggest number in entire lot. 10 is biggest number, means big number, higher priority. If that is the case, after P4, which is having highest priority, can you tell me, type down in the comment box, which process is having next priority, next highest? After 10, next highest is 9. So 9 will have next priority, then 7, then 6, then 5, then 4. Okay, great enough. Understood that? You guys are understanding or not? You guys are understanding or not? Yes, it is very easy now to understand. Very easy to understand. Yes. So given directly that 10 is highest number, biggest number, and priority also highest. Hence, what I will consider here, bigger number, big priority, high priority. Smaller number, low priority. Okay, fine. Okay, let's solve this question now for non-preemptive version. Same to same question. This one, exactly same question we will solve for the preemptive version also. So let's solve this question with non-preemptive version. In non-preemptive version, what happens? If a process is given to run in CPU, then it will completely run. Even though if later on a new process arrives which has higher priority, then too we will not continue that process. Means we will not preempt that process, we will continue the same process. No, we cannot preempt by non-preemptive version. So at time 0, the Gantt chart starts from 0. You tell me at time 0 what all processes have arrived. At time 0, what all processes have arrived. When will you start Hindi on YouTube? Beta, for Hindi we have another channel, Wallah CSEC Electrical. On that channel we will start later on. So at time 0, only one process P1 has arrived. No any other process option we have. Yes, good. So P1 will be executed completely. Yes, non-preemptive. एक बार जो मैंने कमिटमेंट कर दिया तो फिर मैं अपने आप की भी नहीं सुनता. There is a Hindi dialogue here. Yes, from the movie. So once you have given a process to execute, it will completely execute. It will not listen to even operating system also. So P1 will run completely. What is the burst time of P1? 4. So till 4 time unit P1 runs. Now till 4 time unit, look at this. At 1 time unit P2 arrives. At 2 P3 arrives. At 3 P4 arrives. At 4 P5 arrives. Now these 4 processes you guys are having in the system. These 4 processes arrived? Yes. Now among these 4 processes, which process you will learn? You will run next. You will run next based on priority based algorithm. So you will use the priority. What process is having highest priority? Among these 4, which process having highest priority? Sir, highest priority having P4. So P4 is having highest priority. Let's run this P4. We will run P4 for how much time unit? Burst time of P4 is just 1. We will run P4 for 1 time unit till 5. Okay, now till 5, we have these process available. These process available just because at 5 P6 also arrives. Among these two and these two, which one is having highest priority? 9 is the next highest priority. Burst time 2, P5 runs for 2 time unit up to 7. Done. Next, no any new arriving process? No. Then based on the priority, highest to lowest, let's run. So this P1 done, P4 done, P6 done, P5 done. Now next priority is which one? Next is this one, P6, 7 time unit, 9. P6 priority is 7, 6 time unit. 6 time unit, 6 time unit, 7 plus 6, 13. Next is which one is higher priority? Sir, 6 is higher priority. For 3 time unit, P3 we will run 16, and at the end 5 priority, P2 will run 2 time unit 18. You know guys, there is one place where 90% students make mistake. What is that, you know? When I say here, next process you run P5, just because P5 is having priority 9, most of the student, what they do, priority is 9, P5 will run, and they run P5 for 9 time unit. They do that, I know that. They run P5 for 9 time unit. Array, 9 is not burst time, it is priority. Burst time is 2. So they take what? They take priority as the burst time. Please don't do that. And I am 100% sure at least one among you guys who will practice the question will make this mistake. Concentration is the main part here. If you guys are okay with this particular Gantt chart, we will go ahead further. Big fan. Thank you so much. I am also big fan of your learnings. If you guys are okay with this, rest of the things you can calculate. Completion time, turnaround time, and waiting time. That's so easy. Completion time of P1 is 4, P2 18, P3 16, P4 5, P5 7, P6 13. And then turnaround time is for each process completion time minus arrival time. Waiting time is turnaround time minus burst time. Rest of the things are simple, same to same. So I am not bothered about it just because I know you guys can do it. You practice it, write down your answer, and easily you can get it. Okay. Next thing, let's solve the same question with preemptive version of the priority algorithm. Preemptive version. What it changes? Sir, in the preemptive version, we know that if later a new process arrives, which is having higher priority, then the lower priority process will be preempted out of CPU, taken forcefully out, and higher priority process will be scheduled to run in CPU. Okay, so let's do this at time 0. Right now we do have only one process arrived, P1. Fine. So we will start running P1 without checking it. Priority, etc. I'm not checking. But P1 I will run till next process arrives. P1 I will run only till next process arrives, and I will check. Should I continue P1 or stop P1? That decision will be taken based on new processes priority. Okay. So P1 I will run till when? Next process arrives at 1. Next process arrives at 1. I'll run P1 for 1 time unit. If I am running P1 for 1 time unit, P1's burst time remaining is 3 now. Okay, now at 1 time unit, P1 was already running in CPU with priority 4. P2 arrives with priority 5. Which process is having higher priority? Which one? Which one is having higher priority? You tell me. 4 or 5? Sir, 5. Just because 10 is highest, greater number higher priority, 5 is higher. P2 is having highest priority. If P2 is having higher priority, what should we do with P1? तेरा क्या होगा रे P1 वाह? what will happen to you, man? P1 will be preempted and P2 will be scheduled. Why? Just because new process having higher priority. So P1 is preempted, P2 scheduled. Now P2 also, I will run till next process arrives. Next process arrives at 2. So I'll run P2 for 1 time unit till 2. Remaining burst time is just 1. And at time 2, another process arrives P3, which is having even higher priority than running process P2. So P2 having priority 5, P3 is having priority 6. P3 is having higher priority, P2 preempted again. So P1 also preempted, P2 preempted by P3, P3 will run now. P3 I will run 1 time unit only. Why? Sir, at 3 time another process is coming, P4, and P4 is having highest priority. Okay, P3 if I have run already 1 time unit, remaining is 2. Now at 3 time unit, highest priority process comes. Anyway, P3 will be preempted. P3 preempted, P4 goes to CPU, runs how much time unit? 1 time unit, 4, and done. At 4 time unit, P5 arrives and P5 is having priority 9, which is greater than all these 4, 5, 6 which are there in the system. 4, 5, 6 greater priority 9, we will run P5. P5 I will run for 1 time unit till 5, just because at 1 time unit, 5 time unit, another process is arriving which is P6. At 5 time unit, P6 arrives. Now I'll check P6 is having higher priority. Then P5, no, P5 is having higher priority. So I'll continue P5. I'll continue P5 till what time unit? Till 6. And P5 completed. Now, is there any new process arriving? No. I don't have to worry about preemption then. Preemption can only occur when later we have any arriving process which has higher priority. Otherwise, continue. Among all remaining, we are already executing highest priority process. So you don't have to worry about it. Now, these 3 are still remaining and last one is remaining. Highest priority process is this one, P6. So we will run P6. Complete P6 we will run for 6 time unit till 12. Why? No any new process arriving. So this will remain highest priority process. Next, we will run 6 priority, P3, 2 time unit till 14, done. Then 4, 5 priority, P2 we will run for 1 time unit, 15, and 3 time unit till 18, P1 we will run at the end. Total 18 time is the burst time of all the processes. Yes, 9 and 10 plus 8, 18. Yes, that is correct. So this is the Gantt chart we will be having. We should have here 6. Please check it out if you guys are okay with this. If you guys are okay with this, please check it out so that I can make sure that, okay, whatever I explained, you guys understood. See, I am again telling you guys once again, many a times I have explained this particular concept to you. Concept of not technical things, concept of learning. My motive is to make you guys achieving your goal. You will say, sir, that is my motive also. Means your motive also. Yes, you and me both are working for the same motive. And that motive is what? That target is what? Your success, your career. And I am also working for your career only. My entire hard work is to make you guys successful, to make you guys reaching to your target, whether it is PSU, government job, MTech, PhD, IIT, IISc, IIM, whatever it is. My job is to reach over there, to make you reach over there. If you open, social media and all, you can see a lot of people have reached to their level this year. Thousands of people, thousands of students, a lot of were there connected with me, and my job was simple, to guide them. If you guys are ready to spend your mental energy, physical time, and everything towards your career, I am more than ready to help you guys. Okay, now if you guys are understanding everything, let's solve this question for non-preemptive. It's a practice question for you guys. I'll give you 3 minutes to solve. Priorities are given, burst times and arrival times of each process given. Just solve this question. Only Gantt chart I will need from your end, non-preemptive version. That's it. Only Gantt chart will also help here. Solve this question. I'll give you 3 minutes to solve it. I am here only checking out. If you guys are stuck somewhere, not understanding anything, just let me know. If you will practice, then you will be able to solve the questions. When you will be able to solve the questions, then only you will be able to get the marks in the GATE exam. Go ahead. Done. Okay, one person is done, remaining still doing it. Okay, let's see. How do we solve it? Non-preemptive is always easy. At time 0, we'll have to see what processes arrived. Sir, time 0 P1 only arrived. So we will start running P1. P1 we will run completely without checking its priority just because it's a non-preemptive version. Burst time 7. So till 7 p.m. P1 runs. Once till 7 time unit P1 runs, till 7 time unit all processes will arrive. At 1, 2, 3, 4, 5, P2 to P6 arrived already. Now I'll have to solve or I'll have to run them, execute them based on highest to lowest priority. We'll see highest priority is this one given in the question. So smaller number, higher priority given, highest priority is next to P4. P4 will run for next 2 time unit. Let's run P4 for 2 time unit till 9. Next priority is 2. We will run P3. P3 for 5 time unit, 14. Next priority is 3, which is P5, 6 time unit till 20. Then next priority is 4. 4 is next priority, 3 time unit P2 we will run 23, and at the end priority 8, 1 time unit P6 we will run 24 and done. Can you please confirm if you guys got the correct answer same to same? I'll confirm 7 plus 3, 10, 15, 17, 18 and 24. Yes, till 24 time unit, all processes will run. This is the Gantt chart for you guys also for non-preemptive version. Confirm once. Got the same answer or not? Yes or no? Here you can lie also. It's your choice. If you get even wrong answer, even if you don't solve the question, you can say, "Ha, sir, we got the same answer, same to same." Problem is, here you can say lie, okay, no problem. But if same question comes in gate exam and if you don't able to, or if you're not able to solve the question, then what happens? Gate people will not trust that you got the correct answer, and hence they will award you 2 marks. Practice, you will have to do, guys, practice. Okay, now same process scenario. If we will solve for preemptive version, what happens? Some different answer will come. Just check it out how the processes will be executed in preemptive version of the same process scenario. Again, 3 minutes I'll be giving you to solve the questions. Three minutes. Just 3 minutes. I'm sorry. Same question we are solving for the preemptive version. That becomes little difficult. Yesterday I have explained you guys, you can have a ready queue also if you are not comfortable with solving the question directly. Maintain a ready queue at what time which process comes. You can compare among these processes which one I will execute next. One more minute I'll give you. Okay, done. Let's see. At time 0, only one process P1 arrived. Rest all are arriving later. So we will start running P1. P1 runs for one time unit. Remaining is 6. Why only one? Same. At one time unit, another process P2 arrives. As per the priority values, one is highest, smaller value, remaining are greater. So 9 and 4, smaller value, higher priority, P2 has higher priority. So when higher priority process later arrives, we'll have to preempt P1. P1 preempted, P2 runs next. I'll run P2 for one time unit another. Its remaining time is just 2 now. And at time 2, P3 arrives, which is having higher priority than P2. So P2 will be preempted, P3 will run. P3 will run for another one time unit till 3, and I'll have to stop it. I'll see later on. Remaining time is 4. This updation is very much important. Please remember, these things you'll have to update. Otherwise, one time unit P3 you have run already, and later on you will run 5 time unit more. Because of that, turnaround time, completion time, etc. will change. Because of that, your values will change. You may not get the correct answer. Okay, so P3 will run one time unit, remaining is 4, and at 3 time unit P4 arrives, which is having highest priority. So if P4 is having highest priority, without thinking, I can understand that P4 will completely execute. For next 2 time unit, I am running it. I am not bothered about at 4 time unit another process comes. That is the intelligence I am making here. I am putting up here. I am using intelligence. What is that? Sir, even if at time unit 4 another process arrives, that is not having higher priority than the highest priority process. No. So we will anyway continue P4. We cannot preempt it. Preemption only can happen when later arriving process has higher priority. This is having highest priority, later one is not having higher, then we will stop. We will not preempt P4, we will continue P4. So P4 completed, yes. Now what? Next is what? Till 5 time unit, now we have these 3 processes remaining, and these 2 are already there, P5 and P6. Which one is having highest priority? P2. P2 is having highest priority, sorry, P3 is having highest priority. We will complete P3 next. P3 will be completed for 4 time unit till 9. Why? Why you are running completely, sir? No any next process arrives. So no process arrives means no preemption happens. Okay, next priority higher one is 3. So for 6 time unit, P5 will run till 15. Then after that next priority is this 4. P2 will run for 2 time unit till 17. Done. Then next priority is 8. P6 will run for 1 time unit. 18. Then last 9. P1 will run for 6 time unit. 20. This is the Gantt chart. Just check out if you guys are okay with this Gantt chart. Understood everything here? Just check out if everything is understandable, then we will move ahead. Only creating the Gantt chart is important. Rest of the things are same to same as we have seen already in last 3 days. Okay, if everything is fine, then the priority based algorithm has some advantage and disadvantage. What is the advantage? Response is really good in real time systems or real time situations. See, in real time situation, me as a user want to get quick responses from that process which I am running currently. Let's say I have opened WhatsApp, or let's say I have opened web browser in my laptop. So I want as a user that this web browser should give me quick response. Why? Just because I'm interacting right now with that process only. So in such case, you know what happens? Those processes for which user needs quick responses will be given higher priority, and those will be running first so that user can get the quick responses, better responses for such processes. In the real-time situations, better response can be taken out. Priority-based algorithms. Disadvantage is low priority processes may suffer from starvation. It might possible that there is a low priority process P3 and that is not executing right now just because we have P4, P5 and P6 higher priority processes. Till these 3 processes will run, another 3 processes arrive, P7, P8 and P9. Those are also having higher priority than P3. So P3 again will wait. When these three processes will run, another 2 3 processes arrive, 10 11 12, and those are having even greater priority, higher priority than P3. So P3 will wait till what time it will wait? Till all these higher priority processes are over. If higher priority processes are not getting over, then P3 wait for not yet known or undefined time, indefinite time. And that is what the starvation. Low priority processes may suffer from starvation. Okay, what is the solution, sir? Do we have a solution of starvation here in priority based algorithm? Yes, called as aging. See, I do have a very simple example from our real life. When I was just 4 5 year old, in my household, there was no any decision which has been taken, which was being taken with my you know intentions or from my permissions. No. From my consent, no. Even whatever I was wearing, the dresses, those were also I was not deciding. My parents were deciding, just 4 year old. When I used to when I spent little more time, when I become little older, I started wearing clothes which I wanted to, which I wanted to select. Okay, no, 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 mama, this color I want to wear. My mom used to give me that cloth at that particular time. But still, bigger decisions, nobody was taking my consent or any permission or any kind of respect was not given in my house. Later on, when I have become little more older, for the tech things like mobile, laptop, etc., to purchase such kind of things, my parents started asking me, giving me priority. That okay, which mobile to take? You tell me. What to take? Which particular mobile service, Idea or Airtel, etc., to be taken? So those kind of things, slowly, they started taking permissions from me. Now, everything they have put on me only. 99% decisions they have asked me to take only. You take only. You take the life decisions. You take everything about you and for us also. If we are traveling, through which train we will have to travel, you decide and book. If we are purchasing something, some dress or something, you decide which particular shirt or which particular pant and just purchase for us. Give the money, give the permission, both you only give. That is the situation. How it has happened? By aging. When I was aging, when I was getting older, I have become the highest priority process of the house. What is the situation is your house? Does anybody take your permission or consent about any decisions? If your parents will have to take some big decisions, they are taking your permission or consent? Is it good or not, etc.? Or they are not giving you any kind of priority? If not, don't worry. Once you will age more, they will definitely consider you. Hmm? So this aging is same thing. What aging says? Aging says that the system will have a priority which can change, called as dynamic priority. If a process is waiting for little longer, then its priority is increased by 1. If another process or same process waiting for same duration of time again, process priority increased by 1 again. Like this, if a process is waiting for very long, its priority periodically will increase, and at certain point of time the process will become the highest priority process. So aging is something like increasing the priority of the process which is waiting for little longer, so that after some time, increment, periodic increment will make this process highest priority process, and this process will get the CPU, will not wait infinite or will not wait for indefinite time. That is called as aging. I'll write down this. Increase priority of a process periodically by 1 if the process waits for a predefined time. So if a process is waiting for a predefined time, its priority is increased periodically by 1. This increment will make the process, of course, that process whose priority we are increasing, highest priority process, so this increment will make the process highest priority process at some point of time. Hence, process will be scheduled to run on CPU. Process will not wait indefinitely again and again and again. That is called as aging. But this aging can be done only when dynamic priority of processes are used. Applicable only when dynamic priority of processes are allowed. Okay, when processes are having dynamic priority, then only this aging is applicable. Cool enough. We have a question now. A GATE 2017 question from the preemptive priority scheduling algorithm. So this is the priority burst time, arrival time of 5 processes given, and you will have to calculate average waiting time of the processes. Read the question and solve it. I'll give you 3 minutes to solve it. Three minutes in total, I'll give you. 3 minutes in total. Okay. A done, 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 done. Fine. Okay, let's see. Consider the set of processes with arrival time in milliseconds 0, 5, 12 to 9. CPU burst time in milliseconds, these, and priority 0 is highest priority. 0 highest, which means 1 is next, 2 is next, 3 is next, and 4 is the lowest priority. Okay, show below. Okay, none of the processes having IO time. IO time is not there. Fine. The average waiting time of all the processes should be what? I have brought all the processes, same thing here, so that I can solve the question here. Look at this. Which particular priority? It is preemptive priority scheduling given in the question. Preemptive, okay? So let's solve this with preemptive scheduling. So with preemptive scheduling, first of all, at time 0, we have only one process P1 available. We will run P1. We will run P1 till next arrival 2. Next arrival at 2, P4 arrives. So burst time remaining is 9. Now, see, the thing is, it should not visible. At 2 time unit, P4 arrives. P4 is having priority 1. P1 is having priority 2. Of course, P1's priority is low, P4's priority is higher. So P4 will be scheduled next. P4 scheduled next. 0 is highest, 1 is next, 2 is next. So P4 will be scheduled for next 3 time unit up to 5. Why? If up to 5 only next process is arriving. So 3 time unit up to 3 time unit, if we are running P4, remaining is 7. Okay, I'll update it. 7 remaining. Now at 5 time unit, highest priority process 0 priority arrives. Highest priority process with 0 arrives. P2, so P2 will be scheduled next. For sure, P2 will complete. I don't care even if later on processes arriving. I don't care. I'll have to run P2 completely. Why? Just because P2 has highest priority. Highest priority 0. So P2 will completely execute till 28. 5 plus 28, 33. Done. Till 33 now, other all processes arrived. Okay. So I don't have to care about when which one will arrive. Now I will run the processes with their priority order. 1 priority next, P4 will run for 7 time unit till 40. Done. Completely done. Then next priority is 2 priority 2 9 time unit P1 runs 49. Then next priority is 3 2 time unit P3 runs. And then last 4 16 time unit P5 runs. 15 time 66. Okay, I'll continue further, but before that I'll just understand if I did correctly or not. 28 plus 2 30, 40, 50, 51 and 16. 51 and 16, I should write 67 here. 67, yes, cool enough. Now everything is done. Let's fill up the completion time, turnaround time and waiting time. What is completion time of P1? P1 completes at 49. P2 completes at 33. P3 completes at 51. P4 at 40. P5 at 67. Turnaround time is completion time minus arrival time. 49 minus 0. 33 minus 5. 51 minus 12. 51 minus 12. 39 and 10, 39. 40 minus 2, 38. 67 minus 9, 7 and 2 more, so 58. Waiting time, turnaround time minus burst time. 49 minus 11, 38. 8. 28 minus 28, 0. 39 minus 2, 37. 38 minus 10, 28. And 58 minus 16 is 42. Now let's calculate the average of all these. Average waiting time. Big values are there. Yes. 38 plus 0 plus 37 plus 28 plus 42 divided by 5. Okay, let me calculate. 38 plus 37 plus 28 plus 42 divided by 5, 29. Average waiting time of the processes is in millisecond. Answer is 29. That is the answer. Just see once if any calculation mistake I have not done. Just check out if I have not done any calculation mistake. Okay, fine. Then if everything is cool enough, done, we are done with the priority based algorithms. I'm sorry. Priority based algorithms are following priority of the processes. Whichever process has highest priority, that process will execute first. Preemptive, non-preemptive, both type of algorithms these are. In the question, whichever type given, like in this question given that you'll have to use preemptive version, we were using that. If in question they say non-preemptive, we'll go with non-preemptive. Read the question carefully. Read the question about the priority also. Highest priority is lower number or higher number. Based on that, you can decide higher priority is which process against the other process. And easily you can decide continue this process only or preempt this process and run next one. Fine. Next time we will meet tomorrow and we will solve the questions of round robin. Yes, round robin is little different than the regular method. So please be aware of the fact. It is important also and you guys will have to learn how to solve the questions also. So see you tomorrow with round robin algorithms. Till then you guys enjoy the learning. Please cover up the remaining sessions if you haven't covered and like the session if you are enjoying. If you have any answer of any question, drop in the comment box your answer or queries and we will review that particular thing. Thank you once again. Have a great day. Happy learning. Bye bye. Good night.